Hey guys, thanks for watching this video for your day 5 notes and homework. It's kind of a combination of the two together. If you're able to print these notes from Google Classroom, awesome. If not, just take a moment to draw yourself a quick triangle here. Make sure it's right triangle. We're going to start with a 45, 45, 90. This hypotenuse is 1. And then in a few minutes, we'll get to the 30, 60, 90 as well. You are going to need to upload a picture of this when you finish to Google Classroom to show that you've done it. So don't forget to write it down. All right, so if I take a look at this first triangle of 45, 45, 90, I want to use the special ratios to find and label the lengths of each side. So I've already got that this hypotenuse is 1. In a 45, 45, 90, I know that these two legs are congruent. They are equal to each other. And I'm remembering the ratio for leg to hypotenuse is 1 to 1 to root 2. So when I set this up, I'm going to do my leg over my hypotenuse equals the leg I don't know. I'm going to go, actually, wait, sorry. Can I do the ratio first? Sorry. I know that I'm trying to find the leg and the hypotenuse, so I'm going to use that ratio, 1 over root 2. And then I plug in what I know. The leg I don't know. The hypotenuse is 1. So I'm setting up that ratio. Of course, remember, you can always put the hypotenuse on top if you want, and the legs on the bottom. You just want to be consistent throughout the whole problem. From here, you want to cross multiply it to solve. So 1 times 1 is 1. Root 2 times L. 2 times L. Got to get L by itself. Dividing by that root 2. We are going to need to simplify that. Remember, there's a rule in math that we don't like square roots left in the bottom, so we multiply it to the top. It's called rationalizing the denominator. That's going to give me a root 2 on top and just a 2 in the bottom. That doesn't simplify any farther. So my legs, both of them, because they're congruent, are root 2 over 2. Remember, because this is a video, you can always pause this and rewatch any parts that you need to speed up or slow down as needed as well. Okay. Moving on to the 30, 60, 90 triangle. Let's see. The hypotenuse is across from that 90-degree angle, so my hypotenuse is 1. Across from the 30-degree angle would be my short side. This guy would be my long side because he's across from the 60 degrees. All right, so to find his sides, I need a new ratio. For a 30, 60, 90, short to long to hypotenuse is the ratio 1 square root of 3, 2. So let's say I wanted to find the short first. I'm going to use the hypotenuse that I have, short and hypotenuse. So set up that ratio is 1 over 2, short to hypotenuse. And this time when I know the hypotenuse is a 1, that goes in the bottom. Short, I don't know, make it an S. You can also use any variable you want. And now we cross multiply to solve it. 1 times 1, 2 times S, divide the 2, and our S value, our short side, is 1/2. For your long side, oops, oh my goodness, I'm so sorry. Blame it on the Friday afternoon that I'm doing this, sorry. I realized here when I set up my fraction, I put short and long. That was not right. I should have been short and hypotenuse. The hypotenuse was 2. The hypotenuse I know is 1. So my math is correct. I just did my wrong letters over there. I apologize for that. Let's look at how to find the long side now. I'm going to use my hypotenuse value that was given. You could use the 1/2 short if you wanted, but remember I said that if you make a mistake with your short and then use it to find your long's also going to be wrong. So I always go back to what's given. So I'm going to use my hypotenuse again, but this time do it with the long. So let's see if I can get my letters right. Long and hypotenuse. That ratio is √3 for long, 2 for hypotenuse. And I know the 1 is my hypotenuse, that goes on the bottom. Long, I don't, put an L or some variable. Cross multiply to solve it. Divide the 2 out. And that does not simplify, so just √3 over 2 is my long. All right, feel free to take a second to pause this, rewatch that, anything you might need before you move on to the next part. So what is the next part? The next part is a chart here. If you're doing this on paper, pause, take a minute to draw it. It doesn't have to be perfect, but make sure you're writing down the table or the chart. The first thing I'd recommend we do is take our 30, 45, and 60 degree thetas, our angles in degrees, and change them each into radians. So if I have practiced and memorized them, you should have known them for the quiz. We did them before winter break. 30 degrees is one that we want to memorize. He is pi over 6. And 60 degrees is pi over 3. I think we talked about how the 3 and the 6, like they don't match, they're opposites. Pi over 3 goes with 60 degrees. Pi over 6 goes with 30 degrees. And hopefully you remember the 45 degrees as well. That 4, it's pi over 4 is how I remember it. 45 degrees is pi over 4. All right. So moving on in the table, this first box here, it's asking me to do sine of theta, and it's giving me these different theta values, either in degrees or in radians. Our brains probably would prefer degrees right now, so let's do that. So sine of theta, this is saying sine of 30 degrees. To find sine of 30 degrees, I'm going to use SOHCAHTOA and the triangles that I did in the last screen. Okay, so when I say 30 degrees, I am looking at my 30-degree angle here. Yeah. And I'm gonna maybe identify who is the opposite, the hypotenuse, so I've already got hypotenuse, and adjacent to 30 degrees, labeling that triangle so that I can use those sides, the 1/2, the √3 over 2, and the 1, to do sine. Okay, so thinking of sine, sine is opposite over hypotenuse. So the opposite is 1/2 over the hypotenuse is 1. So 1/2 over 1, opposite over hypotenuse. And now simplify that if possible. Dividing by 1 is kind of silly, right? That's just going to simplify to be just 1/2. Rewatch it if you need to. Let's do the cosine of 30 degrees next. Cosine of 30 degrees, going on in my SOHCAHTOA, that's the ka, adjacent over hypotenuse. So look back at the triangle you drew. Try to write the fraction adjacent over hypotenuse. What number is adjacent? That's the √3 over 2. Over the hypotenuse is just a 1. Divide that, it's just √3 over 2. You don't need the over 1. You can simplify it. Last one of these is tangent of theta. Tangent of 30 degrees. So we're still looking at that 30-degree triangle. Opposite, adjacent, hypotenuse are labeled. Remember that tangent is TOA, opposite over adjacent. opposite over adjacent. So my opposite is 1/2 over my adjacent is √3/2. Take a second to make sure you feel comfortable with that. Rewatch if needed. Opposite over adjacent. How can I now simplify this? A fraction divided by another fraction. Remember, to divide fractions, you multiply by the reciprocal. Multiply by the reciprocal. So this 1/2, keep, change, flip. Maybe you remember those words from your Algebra 2 teacher. Keep, change, flip. You're going to keep the 1/2 the same, change it to multiply, and flip that second fraction. Gets you to here. We can simplify this more because the 2's can cancel. When there's multiplication in the middle, we can cancel tops and bottoms. So now we have a 1 on top and a √3 on the bottom. Simplify a little bit more. I know you're getting tired. Simplify this, get rid of that square root in the bottom, multiply it up to the top. You're going to get a √3 on top and just a regular 3 on the bottom. So tangent of 30 degrees after all that work is √3/3. All right, we're going to try the same thing for 45 and for 60. If you're feeling pretty good, why not try it for yourself? Pause, work ahead, and then you can like zoom through, speed me up when you're trying to watch and see if you get it right. Okay? If you're not quite ready to try it on your own, maybe you'll be ready to try it on your own when you get to the 60. Okay? All right, so the 45 degrees. So now I'm going to focus my attention on the other one, this triangle. Circling it in pink. 45 degrees, I'm going to leave it here and think about my opposite, adjacent, and hypotenuse. Cool. So this guy would be the opposite. This guy's still the hypotenuse, and this leg would be my adjacent. So if the question in the table is asking for sine of theta, sine of 45 degrees, which is the same as saying sine of pi/4, it's just changing the angle into radians instead of degrees. We could do it the same way. Sine of 45 degrees is going to be opposite over hypotenuse again. So find your opposite, find your hypotenuse, and write that fraction. Did you get it right? Simplify this. Dividing by 1 is not necessary, so it would just be √2/2 for the simplified answer. Let's try cosine of 45 degrees, or cosine of pi/4. Doesn't matter which way I put the angle in degree units or radian units, we still find it using the same SOHCAHTOA. So I'm thinking adjacent over hypotenuse, adjacent over hypotenuse. Adjacent over hypotenuse. Simplify it is just √2/2. Hope you're starting to get the hang of it a little bit. Let's try tangent. Tangent of 45 degrees is TOA. So looking at my opposite over my adjacent, opposite over adjacent. To simplify this, you can do keep, change, flip again, or you can recognize that you're dividing something by itself. √2/2 divided by √2/2, it's dividing it by itself. So when you divide something by itself, it is just 1, not 0. Be careful. It's just 1. 10 divided by 10 is 1. X divided by X is 1. √2/2, divided by root 2 over 2 is just 1. All right, if you're feeling good, try the 60-degree by yourself. When you go to the 60-degree, you're using this same triangle that we started with, but we're looking at it from a different perspective. So I think I'm actually going to draw a new one just so I can see it better. It's so messy, I don't want to confuse my brain. It's not perfect, but you'll work with it, right? We said this guy was the 1/2 was the short, and the root 3 over 2 is my long. Now, instead of looking at it from the 30-degree perspective, I'm going to put in just the 60-degree and focus here. Re-identify who's opposite, adjacent, and hypotenuse. Hopefully your work matches mine. Opposite the 60 would be this long side, the root 3 over 2. Across from the 90, the 1 is your hypotenuse. That means your adjacent is going to be the short side, the 1/2. Let's try finding sine of 60 degrees. Going back to SOHCAHTOA, opposite over hypotenuse, opposite over hypotenuse, and simplify it. You should be getting root 3 over 2. To do cosine of 60, you're going to do adjacent over hypotenuse, adjacent over hypotenuse. Simplify that is 1/2. And our last one in the table is tangent of 60, or tangent of pi over 3. Tangent is your TOA, opposite over adjacent. Opposite over adjacent. We are going to need to practice here that keep, change, flip idea again. Keep, change, flip. So I'm going to keep the top fraction, change it to multiplication, and flip the 1/2 into 2 over 1. Notice that you can cancel the 2's, and what's left is the root 3 on top. The 1 is on the bottom, which I'm going to drop off because we don't need it, simplified. So tangent of 60 degrees is root 3. All right, from here, I want you to notice the values in here, our final simplified answers. Whoops, one sec, sorry. Let me highlight so you can see them. 1/2, root 2 over 2, root 3 over 2, root 3 over 2, 2 over 2, 1/2, root 3 over 3, 1, and root 3. These values in this chart are extremely important. Sine of 30 degrees, sine of 30 degrees is always 1/2. Cosine of 45 degrees cosine. Looking here, that would be root 2 over 2. Okay, always. Tangent of 60 degrees is always root 3. These values in this chart, you need to start memorizing. Okay, you need to memorize these values. You don't need all of the math of how we got to them. You need the simplified 1/2, root 2 over 2, root 3 over 2, those simplified values that I'm highlighting here. You need to memorize these. This is going to be the foundation of what is called the unit circle. And we're going to be dealing a lot with it next class. And if there's any way for you to know this chart memorized by next class, that would be like amazing and put you so at such an advantage moving into the next lesson. Okay. The next lesson is similar or builds on this idea. And if we take a look at these last problems here, we're going to use this chart to find these answers. Okay, so to find these answers, what are we going to do? Let's see. Sine of 45 degrees. Look in the sine row and the 45-degree column. Sine of 45 degrees is root 2 over 2. Without a calculator, we were able to evaluate this. Sine of 45 degrees is root 2 over 2. Done. Always. 45 degrees is sine is always root 2 over 2. Let's try cosine of 30 degrees using the table. Cosine, look at that row. 30 degrees, look at this column. Find our answer. Root 3 over 2. There's your answer. Always. 30 degrees, the cosine is always root 3 over 2. It goes back to this adjacent over hypotenuse and goes back to those 30, 60, 90 triangles that we drew on the first page. But moving forward, you now have to memorize this chart here. We've explained and understood the background. Now you just know that when I say tangent of 60 degrees, tangent, find that in your chart. There it is, it's root 3. And you don't have to draw a triangle. You don't have to label the sides. You don't have to do SOHCAHTOA anymore. You just know it from this chart. Okay? We can also do it in radians, which is always scary for students, but saying sine of pi over 3 is the same thing as saying sine of 60 degrees. Okay, so find your pi over 3 in your chart, that column. We're talking about sine, so our answer is sine pi over 3 is root 3 over 2. No work required. You have it memorized from this chart. What would cosine of pi over 4 be? Here's your pi over 4 column, cosine row. Find it in the chart. It's going to be this guy here, root 2 over 2. And for my last one, tangent of pi over 6. Pi over 6 is going to be in this column, just like 30 degrees. We're doing tangent, which is at the bottom. Tangent is root 3 over 3. Okay? This is so amazing and so exciting because this is the foundation of the unit circle, which is so important for this entire year. Okay? If you can please, please, please try to memorize this chart. Look at the chart. 1 over 2, root 2 over 2, root 3 over 2. The next row is root 3 over 2, root 2 over 2, 1 over 2. Notice there's patterns in here. Okay? There are patterns in here. So use that to help you as we move into next class. Okay? Maybe try, because you don't have a lot of other homework this week, think about making yourself this chart again and labeling them the degree, or sorry, doing it in degrees and then doing it in radians. Those you should already know. Then try filling out what's the sine? What's the cosine? What's the tangent? Try to fill out those rows to see if you really know them and memorize them and study them. All right? Okay, thank you so much for watching this. It was a bit longer than I had hoped, but I hope it was useful for you. Maybe you were even able to fast forward a bit, which is awesome. Make sure you take a picture of your work and upload it to Google Classroom so that you get credit. Thanks, guys.